When you look at a cartoon of DNA structure, it looks a little bit like a rubber ladder that's been twisted at the top and the base, and that's what gives it that double helix shape. So imagine if you have a ladder with rails along the side and rungs in the middle, and you twist it. That's kind of the look that you get when you take a look at the double helix of DNA. Now the rails are composed of two different molecules, a 5-carbon sugar that's called ribose, and alternating with the ribose molecules up the rail is a phosphate molecule. And you can see this in the cartoon, the illustration that's on the left of this page. It shows along each side these rails that are alternating ribose and phosphate going right up and down the DNA. The rails are actually called the ribose phosphate backbone. They really provide the structure to DNA. Now the rungs are made up of what are called bases, and these bases are extremely important because that's where the genetic code is. The hereditary material really boils down to the sequence of bases that are in the DNA. Now, bases come in two types. There are purines that have 2 rings attached to each other and take up more space, and then there are pyrimidines that are made up of 1 ring and take up less space. And you can see this in the illustration on the left too. It turns out that the space between the rungs is just right to allow one of the 2-ring purines bonded to one of the single-ring pyrimidines. That's the only way it works. If you have a purine and a pyrimidine, they'll fit nicely in the space. You can't have 2 purines between the rungs because that would take up too much space, and you can't have 2 pyrimidines because it doesn't take up enough space. So you always have in the bases a pair of bases, 1 purine and 1 pyrimidine. Now, to make matters more complex, there are 2 purines, adenine and guanine, and they're abbreviated A and G. And there are 2 pyrimidines, cytosine and thymine, abbreviated C and T. And there's an easy way to remember which is a purine and which is a pyrimidine. And it's this: the word pyrimidine has a Y in it. And both of the bases that are pyrimidines also have Y's in it. So pyrimidine has a Y, so does cytosine and thymine. Those are all pyrimidines that have just one ring in their makeup. The purines, the word purine doesn't have any Y's, and neither do the names for the bases, adenine and guanine. So A and G are purines, and C and T are pyrimidines. Now it also turns out that when you have purines bonded to pyrimidines, there are only certain ones that go together. So adenine always bonds with thymine, and cytosine always bonds with guanine. And that has to do with the number of hydrogen bonds that connect these molecules together. I know I'm getting kind of into the deep more than I need to, but I'd like you to know why A and T are always together. It's because adenine can participate in 2 hydrogen bonds, and so can thymine, so they pair up very nicely. Cytosine, on the other hand, can participate in 3 hydrogen bonds, and so can guanine. So they bond well together. You couldn't have adenine, for instance, pairing with cytosine, because that would be adenine having 2 and cytosine having 3, and the bonding wouldn't be right. So this is just a long way of saying A always bonds with T, and C always bonds with G.